Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the Program and Event Manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review two items, our Code of Conduct and Event Guidelines. First, please take a moment to review our Code of Conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. While we do encourage engagement in the chat, please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will share the link to our channel directly in the chat. And if you've not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to access and interact in the chat. You can set that up now. And if you're unable to use the chat but have questions, feel free to reach out to us through social media on Meetup. Oopsie. Looks like this is for later. Sorry about that. Okay, I'm going to bring in our speaker here, Margarita, for the day. Hello.
Hello everyone. Super happy to be here. And you're right. My name is Margarita Ostapchuk, and I am Senior Software Engineer at Microsoft. I'm based in Toronto, Canada, and today I will talk about AI in the cloud.
Amazing. Well, we're very excited for the session. Thank you so much, and take it away.
Yeah, thank you. I want to talk today about AI in the cloud, and I have been working with the Azure Cloud Platform for the last 9 years. And today I want to show you how you can leverage a cloud platform and build AI solutions, with services available on Azure. So we kind of start today with a brief introduction and brief history of AI. After that, we'll talk about Azure, so we're on the same page. We talk about our cloud platform and how you can leverage AI, what services available. Then I will show you several demos, overviews of different services. So we'll talk about some services that are available out of the box and some services that you can customize. And if you prefer, you can build your own solution from scratch. So I will show you kind of high-level overview of the services available and how you can leverage them. We'll talk about some AI integrations, and I will share some next steps. If you're super interested in AI or cloud, I will share some links for you, moving forward, what you can actually create and leverage. So let me then start with this brief history of artificial intelligence. So some of the earliest work in AI was done around 1960s, and the researchers want to explore if it's possible to create machines that could think like humans. Then researchers created programs that could mimic the decision-making abilities of human experts, based on some domain knowledge. And later on, AI research began to use statistical methods and mathematical methods to solve the problem. And this shift was due to the development of new computer hardware and actually made it possible to use larger amount of data and get access to that data quickly. So when we talk about the last 20 and 30 years ago, 20, 30 years ago, researchers start talking about machine learning. And machine learning focuses more on creating algorithms that allow computers to learn from data without being explicitly programmed. And there also was a shift into deep learning and working on neural network with a number of neurons, hidden layers. And in a recent years, in recent year, I can say we start hearing more about generative models, right? Like GPT, 4 and 3 and DALL-E. So those models are able to generate new examples that are similar to examples from a given data set, and also they're used in different fields like natural language processing or computer vision, etc. So we have a lot of interesting technologies available nowadays, and as you can see, and I mentioned in the previous slide, that AI has developed in parallel with computer processing powers, right? So in order to kind of achieve this next level of intelligence in AI, researchers train larger models, more sophisticated models on a large amount of data, and this has required compute power, time, and resources, right? So today, that's why we'll talk about the cloud computing and AI. So cloud computing is important for AI development because it provides a scalable and cost-effective solution. So multiple individuals and businesses can easily get access to the computer resources, or they can store their data, and it's easily available in the cloud. So additionally, cloud computing can help even to deploy your model, right? So when model become larger, maybe the accuracy of that model is higher, but it's also more expensive to deploy this model. So also when you experience this high load and integrated your machine learning solution into your existing product, right? You may expect a high load and large number of requests coming from users. So that's why it's important to scale your model, and also observability can also be one of the areas you can explore. And with the cloud, it can be achieved because it provides infrastructure, data storage for data, and also it can easily deploy the models. So when we talk about Azure, this is on this one slide, you can see Azure Global Infrastructure, and it's made of two key components, right? The first component is physical infrastructure, and the second one is actually connective network. So those physical components is around more than 200 physical data centers arranged into regions and linked by those interconnected networks, right? So that's why when you create a new service, you specify the region. You specify, for example, East US or other region when you create a new service. So I show you just the view of how you can create a storage account. And you can provide resource group, you can provide the region, name of the resource, etc. And you can actually create resources in for multiple environments, for your development environment, staging environment, right, a production environment, and you can kind of group those resources together. This is just to make sure that we're on the same page and know how to kind of we can leverage Azure resources for AI. But today we will focus more on Azure AI, and Azure AI. This is a collection of artificial intelligence services offered by Microsoft. Of course, there are multiple services, as I showed before, services that helps you to store your data, to process your data, to kind of do some smart computations, etc. But we will focus more on Azure Cloud Platform for AI. And those services are designed to make it easy for developers and organizations kind of to add this AI capabilities, right? So there are multiple services. The first kind of group of services, we call them Azure Cognitive Services. And this is a collection of pre-built APIs that allows developers to add capabilities, for example, such as natural language processing, computer vision, speech recognition, etc. to the applications, right? Another one is more focused on some specific scenario-based kind of solutions. So it's Azure Applied AI Services. You can see the form recognizer and other services like that. For example, bots, right? That you can create, and this is for specific scenarios. And another service is actually machine learning platform, and we will also talk about Azure Machine Learning Service, and it allows you to build your model kind of from scratch and deploy to your to production if you like. So Microsoft also has adopted those Azure AI services across wide range of products, and you can also notice there is AI capabilities, for example, in Microsoft 365 services and products available, but we will focus more on the services for developers and data scientists. So let me move forward. And today I want to start with cognitive services. So you can create cognitive services through the portal, for example, as I show here, right? In Azure portal, you can create cognitive service, and it gives you a key and endpoints that you can leverage and send a request. You can use multiple languages for that. A lot of SDKs available for you to use cognitive services. And also what is interesting is that there is other ways, right? You can provision them using Terraform, or Bicep, etc. So it's not only the UI, but I just wanted to show you what is available if you create them from the portal. And now I kind of want to switch to the short demo and show how you can actually call the service from the Visual Studio Code. So I will show the short demo. So in this demo, I will leverage Visual Studio Code, computer vision service, and Python language. So I decided to use Python for the demo, but you can use any other language that you prefer to call the API. And I have Visual Studio Code installed, and Visual Studio Code support Jupyter notebooks. So this is what I'm going to use. And this is a nice tool, and I will kind of call the service cognitive service in order to analyze the image. So let me show you how it can be done, right? So this is the simple code in Python, and I specify here my environment variable. So this is what you saw on the previous slide. I copy keys and I copy endpoints. I added them as environment variables, and from here, from this Jupyter notebook cell, I verify if those parameters exist and provide image path. So for example, in this case, I want to analyze this particular image, right, that I store locally. I send it to the cloud, and I want to get the description of that image. So computer vision helps me to analyze the image and get some interesting information, like description from that image, right? So I can just run this cell, and it returned me the response, a close-up of a bottle, right? So this is a pretty generic information about this image, because this model is not trained on specific set of data, and it's more general, and it's available out of the box to analyze images. And as you see, really relatively easy to write the code to call that particular service. So let me move back to the slides. So when I switch, switch to the slides, I just show you that we can leverage this computer vision and Python. There is other services available. What is other point that I want to show, that you can use the services in the cloud, but sometimes you are not allowed to send your data to the cloud, right? So those services, for example, like computer vision, also available in container. So you can use them locally and only send information about your usage to the cloud, right? And leverage these services in a container. So I show you one demo that analyze the bottle, right, and image of the bottle. I want to show you how you actually can customize that solution, right? Because as I mentioned, the response from the service was pretty generic, right? So to do that, there is a custom vision AI portal available, right? Or you can use actually SDK as well. I just like portal because it's like easier to show what I'm doing here. So you can create a new project and you can actually like provide a name, description, provide your resource. So this is a resource. It's also computer like vision resource. And you can specify what type of project you want to create. There is a classification or object detection project, right? So you can choose if it's multi-class or like multi-label type of project, and even choose the domain so your model are more precise about the like data you're like analyze. And yeah, you can create a new project like that. So I created one, and for this project I used the same kind of like images that I showed you before, but I have like more of them, right? And I want to analyze not only one bottle, but I have like cans and milk bottles and water bottle. So for example, the main request like I receive that I want to get information and basically put those images into different categories, right? I want to understand if it's a water bottle or actually a milk bottle, right? And I want to differentiate between those like images. So in order to do that, I can add my own images and train my model on specific images. The only thing I kind of like need to do is to upload images to that to this tool, right? Tag the particular objects, for example, a can, water bottle, milk bottle, etc. And then once I have like, let's say, enough labels, I can train this model. So I already done that. I actually uploaded the images. This is like from one of the Azure samples, like available like out there, and I trained this model, and it gives me predictions, and it gives me like informations about this particular iteration. As I mentioned, I haven't trained. I haven't tagged all of the images, but I trained on a couple of like tagged images, and I see that I have, for example, precision, recall, and I also have image count. So for some of the images, it feels like I need to add more images or tags in order for this model to recognize better, and it will be like my second iteration because this is only my first iteration for this model. And then once you know how to use your kind of like cognitive service, you can do like the same. So for example, I can send new images and see predictions from those images. For example, I can see that this is a curtain, or this is a like water bottle on this image. So there is like a really easy to build your own custom model, and you can use this model in a similar fashion as I just showed you in Python from Visual Studio Code. It also provides you information how you can actually get access to this model. So this is another type of cognitive services. It's a visual cognitive services, but in this case, you can customize the service and build model that is specific to your data. So let me switch back to the slides. Here, like we discussed cognitive services and we discussed customizable AI cognitive services. Now I want to switch to scenario-based services. And one of the scenario-based services is form recognizer. So it's super kind of like close to what we discussed about like image recognition, but is already tuned for your specific scenario. So in this case, we want to analyze different types of like forms. So it's also images, but they have some specific formats, and they also have like text, right, that we want to recognize. So for example, we have different application forms, so like surveys, like receipts, etc. And in this case, we kind of like want to get insights and extract information from all these forms and get information like data from the tables and text and numbers that we have there. So I want to kind of like also show you how it can be done. So there is, as you maybe already realize, there is a way to do that using SDK, right? And by creating this specific form recognizer like API. So let me switch to my PC again. So, but there is also another studio available that it's easy for you to visualize how it actually works. So you can leverage Form Recognizer Studio, or you can leverage like SDK, right? You can, from the studio, you can drag and drop your like receipts or different type of tables here to see how it actually works. So in this case, I'm leveraging the pre-built like service that helped me to recognize receipts. And when I click Analyze, it sends this information to the cloud, right? And to that particular service that I created. And it gives me the result, right? It gives me a result in the JSON, but in this studio, it's really nice and easy to see that I have the information, for example, about this total and total amount of like money someone spent on that particular like item, right? And it recognizes the key information from that receipt. And also what is nice that it's actually even generate code. So before I show you like how you can call other cognitive services. So this is the code for form recognizer. We can also, you know, if you created the service, you will have endpoint and key similar to what I showed you earlier, and you can just leverage those to call the service and copy this code and run it kind of like from your own environment. There is like other like type of forms available, right? And you can also analyze different types of forms and receipts. There is a different type of pre-built services. For example, you can also analyze business cards, etc. And it gives you like different type of prediction or like analysis based on the different types of data you provide. So it also a service that helps you to analyze the image, but it's kind of like tuned for that particular scenario. So this is the scenario-based services. So let me return back to the slide. Okay, so we already reviewed some of the cognitive services, not all of them, right? We review scenario-based service right now, and now I want to switch to Azure Machine Learning. So with Azure Machine Learning, this is like a platform, right? Like we can build your own model, and this is the tool that actually useful for like different like data scientists and with engineers, right? So no matter how good you like understand machine learning like in AI, you can kind of like leverage this tool because there is like different ways available there for you to create a model, right, and analyze data. So you can take, for example, advantage of the like non-code designer, or like you can also write your own code in Jupyter notebooks, and you can leverage popular like open source tools and frameworks for model training, right? So if you're familiar with PyTorch or TensorFlow or scikit-learn, you can also use those technologies and like frameworks there. Also with Azure Machine Learning, you can build the robust machine learning, like the ML ops pipelines, right? So it helps you actually to operationalize your machine learning model. So it helps you to create ML lifecycle from the building models to deployment and management of those models. It can be done like through the like portal and Azure Machine Learning Studio, and those ML pipelines help you to build the repeatable workflows, and you can use this rich set of like tools available to register your model and track model performance, and track also your assets and data. You can deploy the model as like a service and make it available for your customers, and you can actually manage that model and observe how it actually performs. So this is like another thing that I want to show you. So in order to leverage the Azure Machine Learning like the studio, you need to create the machine learning workspace in Azure. So let me switch to the screen. So here, there are a couple of ways you can build your machine learning models, right? So this is the more providing like more sophisticated ways of building the model. So the first one is by creating your own like notebooks and writing your code from scratch. Another one is automated ML. So it allows you to automatically train and tune your model, and we will take a look how it actually done. And also we have the designers. Designers allow you to drag and drop different components, build the pipelines, and deploy those models. So there's like a 3 different tabs you can see here, and we will start with like automated ML. So automated ML allows you to train your model based on kind of like the data, and it helps you to choose the best model for you. So I will show you how to train a classification model with a no-code AutoML like approach in Azure Machine Learning Studio. So this classification model predicts if client will subscribe to a fixed term deposit with financial institution or not, right? So it's classification. We have data that we will leverage here. What is interesting is that like I can specify what data I use for this model. So for example, you can see here that I have data assets. I can click on the data asset that I will use for this particular model. I can explore this data, right? So for example, this is the data, the first like 50 rows of data, and I have information about different, like about some of the customers, and I want to predict if the customer like will subscribe to a fixed term deposit or not. And I will definitely like filter this data. I will exclude some columns, right? I will like maybe modify like I will kind of like need to maybe like modify some of the data, like scale it or like transform in a particular way, right? Like transform some different columns. So if I have categories, I have data that I can actually like understand, like review the data, etc. So this is we assume that some of this like the data that we will kind of like use for this experiment is like relatively clean, right? So this like pre-work has been done, and now I can build the model. Since I'm here, like in the assets, I just want to also show you that you can monitor your assets from here too, right? So for example, in this case, it shows me that this data is used for this AutoML experiment that I run, and you can monitor where those data, where this data like was used, and you also can like analyze the jobs. So different experiments like you run, different types of models you run, and was it completed, and who actually created these experiments, and how to consume this data from your like Jupyter notebook if you, for example, decide to go that route. So let me return back to the AutoML view. So as you can see here, like I already have one AutoML model, but I want to show you how you can create also one. You can specify the data. So this is the data that we just reviewed. So I just select that one. Then I can specify the target column, right? As I mentioned, I will analyze this Y column, and this is just yes or no for fixed term deposit, like the response from the customer. And after that, I also can specify Azure Machine Learning Compute Cluster. So compute cluster, this is like definitely important, and you can create the cluster where you will run your machine learning experiment, right? You can select different like number of cores, and based on your model, you can specify how big your cluster can be, and I will show you this later. And there is like multiple tasks you can select. For example, you can select one, but there's multiple available. For example, for this particular model, I will run classification model, but you also can use, for example, regression, time series, natural language processing, computer vision, etc. And there is also some hyperparameter configurations, like for validations, you can specify, for example, you want auto or like different type of validation. So this is what I already done, and this experiment actually runs. So when I open this experiment, you will see that this experiment completed, and I use that particular like data set, and I have some information about my data. So for example, here it says that maybe I need to pay a little bit more attention about how I balance the data. So like this AutoML helped me to analyze my data and identify some imbalanced classes. So maybe I will kind of like need to pay additional attention on that. And after that, when I specify the data and specify the experiment, I will like it actually run different models, right, on my like data, and fit my data to those models, and select the best model based on the metrics I specified. For example, here I specify this area under the curve, RFC curve weighted, because of, you can select different metrics based on kind of like your data. Like, sometimes the data is like in balance, so maybe you want to use like area under the curve like weighted, or like you can specify a little bit different like metrics here. And so I haven't specified any of those algorithms, right? So the this AutoML functionality helped me to run all these models on my data based on the metric I selected, and based on this metric, it actually suggested me that this voting assembly, this is the best model possible. And what is nice, that it actually even helped me to explain this model. So, for example, I can analyze what are the top 4 features by the importance for that particular like algorithms, right? I can like analyze and make just to make sure like does it make sense for me, or like I want to use a different model instead, right? There is like other like metrics available. For example, you can select metrics like confusion metrics, and you can specify what other metrics you are like interested in and want to kind of like learn more. Yeah, so there is like other like interesting features here, but when I go to this best model, what I can do, I can actually, as we discussed before, the important thing is how you deploy at the end. So we decided that this is the best model for us right now, and then from this even like UI, you can deploy this model, and then this model will be available for like everyone to consume. For example, I decided to use it as like a web service, so there are like endpoints now like available, and I can use this endpoint and test this endpoint and basically send the data in the similar format. So I can specify all these parameters for that particular model, that particular model is required, and then I can actually consume this model, right? So this is for like the testing. I can specify and test and to see if I like the results. And if you want to build in this model into your code, for example, you even have code example in Python, C#, or like R, right? And it actually shows you how you can use this model and provide you the like REST API endpoint. So this is in like interesting way. It's like relatively easy to choose the best model based on the data you provided, and generate you like end-to-end solution. So another thing that I want to mention, that there is also like designer available. So this is another way for you to build a model. In this case, you can just drag and drop different components into the canvas, but you kind of like will need to build the experiment yourself, but it will create one pipeline that you can use. All right. So as we know, like to build a machine learning model, you kind of like start from data, right? Then you can clean your data. You can specify some specific like columns in data sets that you want to analyze. In the machine learning, we also split the data into like training or like testing set, and use some algorithms on the training data, right? So all these components, this is a drag and drop components that you can use, for example, for data transformation. So you can choose additional component and use that particular component, and or for example, you can evaluate different algorithms. Instead of like linear regression, you can use a different algorithm on your training set. So this is just another way you can create a machine learning model. So comparing to AutoML, where you provide data, and AutoML kind of like choose the algorithm based on the metrics you selected, you provide different components and train your data, like leveraging different like algorithms. And then you also can score and evaluate your model. I also have this you also have this pipeline, and this is something that I just like show you, but I already run that particular pipeline, right? And for example, once in run, I can actually preview the model results, and I can also analyze some metrics that specify, or like I also can analyze the scoring of that particular model. So what it means that, for example, in this particular case, I want to predict the price, so I can compare the price and kind of like predicted score for that particular like metric that I want to analyze. But here I just want to highlight that there is a different way you can create machine learning algorithms. And of course, there is like notebooks available. So in case you want to create your like own experiment from scratch, and you prefer to use like notebook for that, there is a lot of like tutorials and samples available, and it shows you how, for example, you can connect to your subscription, how you connect to your workspace, how you can leverage data you have like register here, and do all the type of like transformations within the notebook. So there is like three different types of authoring available in Azure Machine Learning, and also for like to run these notebooks or AutoML Designer, you kind of like need to create computer instances or compute clusters. Computer clusters allows you to create like multiple like nodes with computer instances, like one instance. And for example, in this particular instance, I'm using like GPU, but you can specify like if you want to use GPU or like CPU, and how big is your virtual machine to run that particular experiment. Yeah, there is also other like components available, for example, like environments, and you can already choose some pre-configured environments and run your experiment on those environments. And you can link other Azure services if you want. So this is the overview of like Azure Machine Learning Studio and like what you can do. And I'll show you the different ways you can create machine learning models from there. So let me switch back to the slides now. So we review Azure Machine Learning. We saw how you can train and actually train your model and publish your model, validate your model, and like then kind of like even create a REST like API and send the new data to that particular API. So now I want to talk a little bit more about the partnership. So I want to kind of like focus more on this, because there are a lot of excitement around this partnership. So Microsoft has formed a partnership with OpenAI to collaborate on the development of artificial intelligence technologies with OpenAI, and this aims to accelerate the development and advance AI system to bring the benefits of AI to more people. So yeah, like this partnership is focused more on developing AI technologies, building AI computing platform, advancing the AI research, and yeah, it makes kind of like these technologies accessible to the wider audience. And by creating like different of these models, you also will be able to create this services in a secure way, and basically leverage all the like best practices and that is available in the cloud as well. So when we talk about this partnership, we talk about the generative AI, and there is like three kind of like main kind of components that I want to discuss here. So the first one is GPT type of like generative AI. This is the text kind of like completion type of service, and this is the set of models basically that can understand and generate natural language based on the prompt, right? You can generate, this model can generate a response. There is another one, another model is called like codex, and this is like actually not a one model, but set of models that can understand and generate code, including like different types of like queries for multiple languages. And there is also DALL-E, right? And DALL-E is a set of models that can generate and manipulate images from natural language like input. So this is like the main kind of like three types of models everyone talking right now. And actually you can also create OpenAI services from Azure as well. So let me actually also switch to my screen, and I will show you what you can do with OpenAI. So if you're familiar with cognitive services, this is like another cognitive service, right? And the cognitive service helps you to create or like tune kind of like your model based on your needs. And there are like multiple models available here, for example, DaVinci or like Ada, and you can read more about those models that are available from like Azure OpenAI as an Azure OpenAI offering, and this is part of like cognitive services offering. So you kind of like use it in a similar like fashion by leveraging endpoint and API key. And then you can actually create a new deployment. You can select one of those models that I show you. For example, in my case, I used a text DaVinci and specify the deployment name. And then I can leverage this model for my specific like task, right? So when to use like which model, this is like really good question. So for example, like ADA or like ADA, like right, like model you can use for parsing text and simple classification or like keywords extraction, right? For example, DaVinci is more complicated model, and it helps you to process like text and do a summarization or understand content like more like precisely. And at the same time, it requires a little bit more compute resources. So you can select, for example, one of the like pre-built scenarios, right? For example, natural language to SQL, right? And you can like generate, and you can generate the response by like leveraging this model as well. So this is like just one example of how you can actually use Azure OpenAI. It's also available in the cloud. You can create, there is like also additional level required for you to get access to this service right now. But once you get access, you can like leverage these models from like the OpenAI Studio or like use the keys and endpoints in similar fashion as I showed you before. Okay, so let's switch back to the slides. And yeah, so we talk about generative AI a little bit. Now I kind of like want to mention that it's important also to think about who and how will use the AI models you created. So when your technology changes the world, you bear responsibility to help address the world that you have helped create. So this is from the book of Microsoft President and Chief Legal Officer. And so this is kind of like the request to think about the responsible AI and such things as like fairness and accessibility of those models is like important, and it's something like to think about. So yeah, like we talk about like the privacy, safety of the models, fairness, inclusiveness, transparency, and accountability. And Microsoft actually worked a lot on AI services over the years. So there are a lot of different recommendations how to make sure that when you build a model, you kind of like keep in mind these principles and build the responsible AI solutions. So when we talk about Microsoft product integration, so I believe you heard a lot of about the current LinkedIn integrations, and I also want to highlight some of them. So with the GitHub Copilot service, you can leverage the Codex OpenAI model that helps you to provide suggestions and some different suggestion how you can run, how you can create code and and improve your code. So this is one way you can leverage some of the technologies now. And another way, the Microsoft announced the Microsoft Designer, whereby providing the some prompt or query or some sentence, right? It will help you to generate images based on the query. So it helps you and inspire you to create maybe more more interesting solutions, or you can get inspired by those. And the other one is, of course, Bing. So there are a lot of also ways before you can subscribe and get access to the service. Now it's you can leverage and ask in the chat and provide your questions, and basically Bing will try kind of to respond by leveraging some of the technologies that we kind of discussed today as well. And if you want to learn more about the AI and different topics that we haven't discussed today, you can find Microsoft Learn Career Path, and you can find there more about different cognitive services and Azure Machine Learning and the different techniques that you can leverage to build your own Azure AI solution. And there are multiple services available out there. So if you want to learn more, there is also a GitHub account with the code samples for Azure, and you can find a specific one for AI. And thanks a lot for joining me today. And thank you. And if you have any questions, I will be happy to answer as well. If not, thanks a lot again for joining, and I hope you found it useful, and can't wait to see your solution leveraging cloud and AI.
Thank you so much, Margarita. I have, it looks like we don't have any questions in the chat just yet. So in the meantime, I'm just going to jump in with a quick slide here to let folks some time to ask their questions if they have any. We are also always happy to receive any feedback that you may have. Tell us if you have a few minutes how you like the session, and if you have any requests on what you want to see next with the reactor, or just any general feedback, feel free to use the link that I shared in the chat right there. And the event code is 19182. And join our community. If you scan the QR code on the screen, you will have access to our website and all of our future events. We are on YouTube. All of our sessions are recorded, so feel free to check out our YouTube channel for previous session on demand and other social media like Twitter, Meetup, and whatnot. It looks like we have a question in the chat. I will let you answer that.
So basically, on tiny edge devices, yes, you can leverage the models on different devices. For example, the question, let me repeat the question. So from someone who's new to ML, can we use this model on tiny edge devices, microcontrollers. There is like a different ways you can like leverage like these models. As I kind of like mentioned, there is different types of models available, right? For example, you can run this model in some like small kind of like containers and run them on like the edge. And you can also, in one of the demos I showed, that you actually can even select the specific type of model for that. So yeah, there is like possibility of running those on like edge devices. You kind of like just need to you just need to keep in mind like how this connect to the internet. If you don't have connection, right, like you kind of like need to find a way, for example, to run this on premise, like in some kind of like on your device, and from time to time have connectivity to the internet. So there is kind of like different ways how you can package your model, and depends how often you have connection to the internet. You can leverage and analyze everything on the device. If it's like super tiny device, right, like you kind of like need to find a way to send this data somehow to the cloud and then analyze there. So it also depends on your like tiny edge device capabilities. It's possible. And for some of these models, you can even like select the specific type, like create tiny model, so it's can be used on these edge devices.
Amazing. Thank you. It looks like we don't have any other questions. Lots of comments, which is great. Thank you all for attending. And thank you, Margarita, so much for joining us today.
Yeah, thank you for inviting. And it was my pleasure.
On to the next one. Have a wonderful day. Bye, everyone.
Bye.